In this video, we are going to look at percentage yield. There are two learning objectives that I'm going to cover in this video. The first one is the definitions of percentage yield, and the second one is on how to perform stoichiometric calculations using more concepts including limiting reagent and percentage yield. Before we look at what is percentage yield, we shall look at theoretical yield and actual yield first. Theoretical yield is the quantity of product formed when all the limiting reagent is consumed in a reaction. So it means that theoretical yield is the predicted yield that we get or we calculated from the limiting reagent. Then what is actual yield? Actual yield is the amount of product that actually obtained in an experiment. So it means that you go to the lab, you do the experiment, and the yield that you get is the actual yield. So actual yield is always less than the theoretical yield. Why? Because when you do the experiment, some accidents might happen, or it might be due to your method, which cause you to lose some of the product. That's why actual yield is always less than the theoretical yield. What's the relationship between actual and theoretical yield with percentage yield? Percentage yield is equal to actual yield divided by theoretical yield multiplied by 100. From this formula, we can see that percentage yield is also referring to percent of the yield that we get from an experiment. So this formula is very important and you must take note of it. When calculating percentage yield, our actual yield and theoretical yield can either be in mass or in number of moles. If your actual yield is in mass, then your theoretical yield must be in mass. If actual yield in number of moles, then the theoretical yield must be in number of moles. For example, in these questions, we are being given titanium metal react with chlorine gas to form titanium 4 chloride. So we are being given the mass of titanium metal is 3 grams. So this is the mass of titanium metal that we have, and for chlorine gas, the mass that we have is 6 grams, and the 7.7 gram of titanium 4 chloride is the actual yield in this reaction, and the question is asking about the percentage yield. So before we calculate what is the percentage yield, we must first analyze these questions first. So these questions give masses for both reagents. So means that this is the limiting reagent types of question. So before we find the yield, we must first identify which one is the limiting reagent. To find limiting reagent, so there are 4 steps. First steps, we must convert all the informations on reagents that are being given to us to number of moles. So we calculate the number of moles that we have for both reagents, titanium, metal, and also chlorine gas. And in second step, we need to find the number of moles needed based on the balanced stoichiometric chemical equations. So from the balanced chemical equations, we know that 1 mole of titanium metal will react with 2 moles of chlorine gas. So now we have 0.06263 moles of titanium. So we are expecting that we need 0.1253 moles of chlorine gas. In step 3, we compare the number of moles that we have with the number of moles needed in a reaction. In these questions, we already calculated in the first step that the number of moles of chlorines that we have is 0.08451 moles, and this number of moles of chlorine gas that we have is less than the number of moles of chlorine gas needed in a reaction, which we have calculated in step 2. So what conclusions can we make? As the number of moles that we have is less than the number of moles needed, so means that the chlorine gas is the limiting reagent. So now we already found our limiting reagent, which is the chlorine gas. So we must use the chlorine gas to determine the amount of products titanium 4 chloride form. In the reaction, 2 moles of chlorine gas will form 1 mole of titanium 4 chloride. So now we have 0.0F451 moles of chlorine gas, so it will produce 0.04225 moles of titanium 4 chloride. To find the mass of titanium 4 chloride, we just need to multiply the number of moles of titanium 4 chloride with the molar mass. And the mass that we obtain is the theoretical yield. Remember, theoretical yield is the yield that we calculated based on the limiting reagent. So this 8.023 gram of titanium 4 chloride we calculated based on the limiting reagent. So this is the theoretical yield. And the actual yield given in the questions is 7.7 gram. So now we can calculate our percentage yield by substituting the actual yield and theoretical yield into the percentage yield formula. So by substituting 7.7 gram actual yield and also theoretical yield into the formula, we got our percentage yield, which is 95.97%. You might want to pause this video for a while to try test yourself one. For further reading, you might want to read Brown's book, page 152 to 153.